Now come to the exercise 2A. Only exercise 2A is required because in the syllabus it's only the quadratic, not the cubic. So now read the question. Find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficient. First we have to find the zeros of the polynomial and we have to show the verification. And this is the first question. There is question number 1, that is x square plus 3x minus 10. We are going to solve it. First we are going to find the zeros of the polynomial. So this is the question number 1 exercise. Exercise 2A. Question number 1. Question number 1, what is it? That is x square plus x square plus 3x minus 10. We have to solve this. So this is f of x, that is f of x is equal to x square plus 3x minus 10. So we are going to solve how f of x is equal to 0. So x square plus 3x minus 10 equal to 0. Now while always compare with the equation. While solving this middle term, always first compare with the equation, that is a general quadratic polynomial ax plus bx plus c. From here what will the value of a? There is coefficient of x square. So coefficient of x square, nothing is there, means 1. Now coefficient of x, in front of x it will be 3. Now constant, that is minus 10. First multiply a and c, only the number, not the sign. A and c, so it became how much? 10. 1 into 10, that is 10. Now find the prime factorization of 10. So 10 will be 5 to the 10. Now we have to make the number this by the subtraction. See the sign here. When it is the when the constant sign is the positive, you have to make this number by the adding. If the sign is a negative, you have to make this number by subtracting. Be careful. When sometimes this number can become by adding as well as we can make it by adding as well as we can make it by the subtraction. But be careful, check the sign here, follow this sign. If it is a positive, we have to make this number by adding. If it is negative, we have to make this number by subtracting. So now we got, and we have to need a subtraction. So 5 minus 2, and we have to use all the number. So this is 5 minus 2, 3. So already we got, that is 5 minus 2 equal to 3. So instead of 3, we will going to write 5x square plus, that is 5 minus 2x minus 10 equal to 0. So multiply it, x square, that is plus into plus, that is 5x minus plus into minus minus, that will be 2x minus 10 equal to 0. Now take the common from these two and from these two, and inside they have to be equal. So that is x square plus, take the common x, so x will be remaining plus x gone, then 5 will be remaining. Here you have to take the minus 2. If you take the minus 2, it will be x is remaining minus, if you have taken minus, it have to be the plus, because if you multiply this number you have to get this number. So plus into minus, that is minus 5 to the 10. So these two are equal, the middle mass, these two have to be the same. So it will be x plus 5, another is x minus 2 equal to 0. So these are the factor of the quadratic equation. We need the zeros of the polynomial. So either that is x plus 5 equal to 0, that is x equal to, take the 5 that side, it will be 0 minus 5. So x equal to minus 5. Another, or that is x, the x minus 2 equal to 0, that is x equal to 0 plus minus, if you go that side, it will be plus 2, that is x equal to. Up to this much we have dealt after the class 9. Now only the values of x, we already know how to find the value of x in the class, means lower standard. Now that value of x, we call it here the zeros of the polynomial. So now the zeros of the polynomial, If you want, you can keep it this is a alpha, if you want, you can make it this is a beta. There is no problem. If while writing, you can consider any of it as the alpha and any of it as the beta. So the zeros of the polynomial are, and already you got the value of ABC. So these are the value of ABC, that is A equal to 1, B equal to 3 and C equal to -10. That also we need. So now the zeros of polynomial are the zeros of quadratic polynomials are, that is -5 and 2. Therefore I am considering first as alpha -5 and beta is equal to 2. Now we need this we got the zeros of the polynomials. Now we need a verification. For verification we need a sum of zeros, and we got write the AB here. The value of A kept 1 we already got, the value of B is 3 and the value of C is equal to -10. Now sum of zeros. What is the sum? Sum is the addition. What is the 0? That is alpha plus beta. What is the value of alpha? We got the value of alpha, that is -5 plus 2. It will give -3. Now sum of zeros. Direct from the quadratic equation. So minus b by a. What is the minus from the formula? What is the value of b? Value of b we got 3, so it will be 3 divided by value of a, that is 1. So if we divide by 1, we doesn't write, so this also we got minus. This and this are equal, so verified for the addition. Now come for the multiplication. Product of zeros. Product of 0. What is the product? That is a multiplication. Alpha into beta. What is the value of alpha? We got alpha, that is -5 into value of beta, that is 2. If you multiply it, that will be -10. Now from the formula from the quadratic equation, product of 0 equal to, that is c by a. What is the c? That is the constant we have -10. A is 1. If you divide by if you divide by 1, it will remain the same. So we got this is the -10 and this is the -10, and the previous this is minus. For the sum we got -3 and -3. For the product this is -10 -10. If you want from here directly from C, sum of zeros from here we can bring up to here. So sometimes it may be complicated. That's why my suggestion, do it separately and make it equal. So these are the equal. So we already got the value, means now already we have verified, so hence verified. Now question number 2. For question number 2, what is the question number 2? What is the Roman number 2? Question number 2, not Roman number 2. This is the question number 2. Is it visible? I think so. That is, here is given that x square minus 2x minus 80. So we know that this is f of x is equal to x square minus 2 of x minus 8. So fx x equal to 0. Instead of fx you can write p of x, that is also correct. What is the f of x? That is x square minus 2x minus 8 equal to 0. So now again compare with the general quadratic equation, that is a x square plus b of x plus c. From here find the value. Coefficient of x square, that is a, so x square, that is 1, a is equal to 1. Now b, coefficient of x, that is b, so in front of x, that is minus 2. And now constant, that is c equal to constant minus 8. Now for solving this, multiply the a and the c, only the number, not the sign. So here is 1, here is the 8. 1 into 8, 8. So now 8, do the prime factorization, 2, 4, 2, 2. Now we have to make the number by subtraction, because here is a subtraction is given. So 2 2s are 4, 4 minus 2, that is we need 2, that is 4 minus 2. So x square minus, instead of 2 you will write 4 minus 2 bracket minus 8 equal to 0. So it will be x square minus plus into minus, that is minus x, that is minus x, okay, minus into minus, that will be plus 2x minus 8 is equal to 0. Now from here take the common. What will be common? X will be common, it will be x minus 4. From here you can take the 2 common, that will be x minus 4 to 8. If you multiply this, you have the we have to get this. So 4 to 8 plus into minus minus 2 into x, that is 2x, x into x, x square, x plus into minus minus x into 4, it will be 4x. Now which one is similar? We write first that x minus 4, another is that is x plus 2 equal to 0. So either that is x minus 4 is equal to, that is x equal to, if you plus, if you go that side, it will be 4, or there is x plus 2 is equal to 0, there is a x equal to 0 minus 2, that will be x equal to minus 2. So we got the we got the values of x. The value of x we call it a zeros of the polynomial. So the zeros of the polynomial, quadratic polynomial are, that is I represent by, okay, here first write 4 and minus 2. We represented it by the Greek alphabet, that is alpha, that is will be 4, and beta, that is minus 2. Now we need a sum of zeros. Okay, write the value of a, b near to this, that is a we got 1, b we got minus 2, and c we got minus 8. So easy to write it down, that's why I wrote it here again. If you know it very well, no need to write it here, only we wrote in the top. So I don't want to bring the pages down, that's why I wrote it here. So now we know this, we are first going to verify the sum of zeros. What is the sum? That is the addition, sum of zeros. So that is alpha plus beta. What is the value of alpha? Alpha we got 4, plus we got the value of beta, that is 2, equal to, okay, 4 plus into minus, that is minus 2, 4 minus 2, that is 2. Sum of zeros, that is equal to minus b by a. Minus from the formula, what is the value of b? Minus 2. Keep the bracket, whenever there is a minus sign, give the bracket. Minus 2 divided by value of a, that is 1. So plus into minus, minus into minus, plus we doesn't write, we do not need to write, so it will be 2 divided by 1. Divided by 1 we did not write, so it will be 2. We got equal. Now come to the product of zeros. So product of zeros. What is the product? That is the multiplication, alpha into beta. What is the value of alpha we got? The value of alpha we got, that is 4 into value of beta, minus 2. If you multiply 4 into, it will give minus 8. We got a minus 8. Now come to the again product of 0, that is product of zeros, zeros, that is c by a. What is the value of c? C is the constant, that is minus 8. What is the value of a? That is the 1. That is 1. So denominator we doesn't write. If the denominator is 1, we did not write. It's not needed to write. So it will be minus 8. Here also minus 8. Here also minus 8. In the sum, here is the 2. Here is 2. This is equal and this is the equal. These two are equal. Therefore, hence verified. Hence, relation between the zeros and the coefficient verified. Hence, the relation is okay. Hence, the relation between the zeros and the coefficient coefficient double fi c i e, okay, coefficient are verified.